Okay, so the sixth question you sent me. Integral of q to the power of 4 times the natural log of q. Alright, so not a normal looking integral, so it's either going to be substitution or parts. If I look at it, I'm not going to be able to integrate q to the power 4 or q and end up with log, and I'm not going to be able to differentiate log and end up with q. I'll end up with a 1 over q, but it doesn't look like the ideal candidate for substitution, but you can try it if you wish. But what we'll try is parts. Now, here's an interesting one here. Normally our guide is we like to choose our u as the thing that will eventually go down, differentiate down to 0. So you naturally go q to the power of 4. So if I differentiate it 4 times, I'd end up at 0. 4 or 5 times, whatever it is. Anyway, either way, it'll eventually go down to 0. The problem is here though, and we've seen it before, when I have high powers here, I end up having to do the parts, integration by parts over and over and over and over again. So you have to do it 4 or 5 times to end up finishing out the integral. So in this one here, what we're actually going to do is we're going to have a chancer arm and that u equals to the natural log of q. And I know when I differentiate that, du dq, I get 1 over q. And du equals 1 over q dq. Now remember, we're doing parts here now, not substitution. So our dv must be equal to q to the power of 4. So our integral of dv is q to the power of 5 over 5. So we can say v is q to the power of 5 over 5. Right, I'll go with my parts here. So the integral of u dv, which is what they gave me, is uv. So we call that q to the power of 5, I'll put my v first, over 5 times the natural log of q. That's just habit. I prefer writing it like that as the other way around. Negative times the integral of v du. So v du. So v is q to the power of 5 over 5. And in this case, du is 1 over q dq. 1 over q dq. Okay. So this will actually work out quite well. So I've got my q to the power of 5 over 5. That doesn't need to be integrated at all. Minus. Now, let's just put this together a bit more. So I've got q to the power of 5 over 5q dq. And I'll tidy that up one more time just to make it easier to look at. Q to the power of 5, natural log of q over 5 minus. Now I've got this 5 underneath the line, so it's been divided by 5. So I'll bring that fifth out in front just to make it easier to look at. And I've got q to the power of 5 divided by q. That's q to the power of 4 dq. And now we're ready to integrate. So I've got my q to the power of 5 times the natural log of q over 5 minus 1/5 times raise the power by 1, divide by the new power. Okay, I won't throw in my plus c yet. So it's up to you here then how you want to do this. We can factorize stuff out, or we can try and get a common denominator and then factorize out. I'm going to go for a common denominator first. So q to the power of 5, natural log of q, over 5 minus top by top, bottom by bottom, q to the power of 5 over 25. I'm going to go with 25 as my common denominator, which means I'll have 5 times q to the power of 5, natural log of q, minus q to the power of 5. Yeah, perfect. Okay, so look, that's a perfect answer, plus c. Different ways to present it. We could factorize out our q to the power of 5s on top, out to the very edge, and we could even bring our 25 out with it if we wanted to. There's no need to do this at all. And have 5 times the natural log of q minus 1. That will do fine as well, but I'd leave it like this. Okay. Anyway, check for any stupid mistakes as usual, and get back to me if you spot any.